All right, problem one. So we want to know which unit is equivalent to joules, kilograms to the -1. So this is going to take a little bit of memorization on our part, just to be clear. So you need to memorize the unit of force is newtons, and you also need to memorize that newtons means kilograms times meters times seconds to the -2, and that the unit on x, position, distance, whatever you want to call it, is meters. So, given that fact, let's smush these units together to get the units of J. And that's going to be kilograms meters squared times seconds to the -2. And now what we want to do is get the units equivalent to joules, kilograms to the -1. So when we go ahead and do that, we're going to have kilograms times meters, seconds to the -2. We square the meters, times kilograms to the -1. These two cancel, and so we're just left with choice D as our answer. Now let's take a look at question number 2. This is a vectors question. I know because we have the word resolve, the word perpendicular, directions, components. All those words give me clues that we're talking about vectors. So here's the deal. We're told that we have one component here, which is the xy direction is along here. That is 4 meters times seconds to the -1. So just to be clear, that component, I'm going to take this little triangle component, copy it, and move it here just to show you the leg of the triangle. And what we want to know is, what's the component that goes along this direction? So that's what we want to know. So I know that this is 5. I know that this is 4. And by Pythagoras' theorem, I know that this has to be 3 meters seconds to the -1. So that's how I'm getting choice B. All right. Now, 3 we're going to skip because I'm actually working this through in the order of the study guide. So this video is going to be dedicated to unit conversions, measurement, error, and vectors. So continuing on, we'll skip 4 and 5, and also this one. So when we talk about the definition of a mole, that's question number 9. Okay. So to be clear, I know we've heard the mole. This is not, so I'm just going to write something here. I would not put this on the exam. It's too hard. But it's a good one to review for later IB related stuff. So, this one's a little tricky. The amount of substance that has the same mass as 6.2 times 10^23 atoms of carbon-12. Here's the thing. This is going to require that I actually measure out this number of atoms, which is going to be really hard to do. The amount of any substance that contains as many nuclei. Well, the thing is, a mole can apply to something that's not nuclei. We can have a mole of eggs if we want. This one's just ridiculous. The amount of substance that has the same mass as 1 atom of carbon-12. Please, how could we do anything practical with that? Moles are meant to measure big numbers. So that leaves us choice D. So let's be really clear. This is the amount of substance that contains as many elementary entities. In other words, it contains as many things. Okay? Objects. I like how they call it elementary entities. Come on. Elementary means basic, and entity means thing. You know, they're just overcomplicating it. There's a number of atoms in 12 grams of carbon-12. See, 12 grams I can measure out carefully. Carbon-12 I can determine the isotope. So really choice D is the choice to measure moles with. And it turns out that this happens to equal about 6.02 times 10 to the 23rd. All right, 10, 11, and 12. These actually end up being way too difficult for us to do, so that's why I actually skipped them on the exam. And then here for the unit, fundamental units here, we're talking about watts, force times distance over time. Once again, this is based on, we got kilograms, meters, seconds to the -2, times distance, which is meters, over time, which will be seconds to the -1st, because over time means 1 over seconds, which is seconds to the -1. And so putting all this together, I'm going to end up getting kilograms times meters squared times seconds to the -3. Let me make absolutely sure I have that right. That gives me choice D. All right, so number 13 gives me choice D. All right, continuing on with number 14. Let's be kind of clear here. So this kind of involves a little bit of physics, so let's just kind of talk about this. We should know that density is mass over volume. So if I'm going to plot mass versus volume, mass against volume, this would be the slope. Okay. Now, in a sense, yeah, we kind of have the right to that you know some basic formulas from other science classes. This is kind of a thing in IB physics that you do remember a little bit. Um, so what that means is that we can say our random errors are small because this graph looks fairly linear. Now you can't do this on the IB, although maybe you could with a ruler. Let me just show you here. Are we getting kind of a linear plot? Let's just see. So when we look here, yeah, this is, it's fairly linear. When we look at that, yeah, it's a pretty linear plot. The problem, though, is when we look at this intercept, we're saying that when you have zero mass, you still have a positive volume. That tells us that we have a nice linear plot, which tells us that our random error is small. Our measurement errors are small, but we got some kind of systematic error that throws our graph off to the right like this. So we have a large systematic error and a small random error, and that's how I'm getting choice C. 15 and 16 we'll skip. We'll do that when we get to forces and other stuff. Same with this. 18 we will never do. It's too complicated. So we'll just kind of cross that off. 19, which is a fundamental unit. Amperes, memorize that. Okay. And then for number 20, we have an oscillator undergoing simple harmonic motion. It has a percentage uncertainty of 12%. So let's kind of be clear here. We've got two formulas. First, when we go into our formula sheet, we have that for division error, we need to remember that delta A over A equals delta B over, it works like this. Delta Y over Y equals delta A over A plus delta B over B, where Y is A over B. That's how we get that error. The other thing, though, is that if Y equals A to the N, then delta Y over Y is going to equal N times delta A over A. So this actually forces us to smash two ideas together. So what we'll say is that delta Y over Y is going to equal here N times delta. So here's how it's going to work when we smash these formulas together. I need the power formula. So that means delta K over K is going to equal N times whatever this error here is. Okay, that's for the power part, because this square root is the same as 2 to the 1/2 power. And then we kind of take our division equation into the problem. So that's going to give us delta K over K is going to equal N times delta A max over A max plus N times delta X naught over X naught. Putting all this together, we have percents here. So our percent error, delta K over K, we don't need absolute, we leave it relative, which is this division thing. That's going to be 1/2 times 12%, because square root is to the 1/2 power, plus 1/2 times 20%. So that's going to give me 6 plus 10. And that's how I'm getting a 16% error right here. That's choice C. 21 we'll do in another video. 23 we won't do at all. That's not going to be something we do. So we'll skip 23. Here. So again, for powers, delta y over y equals n times delta a over a if y equals a to the n. So taking this into account, since the volume is 4/3 pi r cubed, that means delta v over v is going to be, these are all constants, so that's going to be 3 times delta r over r, which is going to be 3 times 2%, and that's giving me 6% error for choice C. For 25, let's get our units. So the units of force, K, V squared. We want to figure out what the unit of K is. So force is kilograms times meters times seconds to the -2 equals the units of K times meters squared, seconds to the -2. Now I'm going to do algebra with units. So I'm going to get kilograms times meters, seconds to the -2, and I'm going to get rid of this meters squared on this side by multiplying by meters to the -2, and I'm going to multiply seconds to the +2, so that's going to be K times meters squared, seconds to the -2, times meters to the -2, seconds to the +2. So these all cancel. When I smush these units together, I'm going to end up getting kilograms here, kilograms times meters to the -1, and that's giving me choice A. Continuing with our work here, so we'll go with problem, so 26 we'll do later, 27 later with forces. All right, this one, units of energy. Let's just kind of continue here. Again, force times distance. This one I hope you get. So it's kilograms times meters times seconds to the -2 times meters again. That's given us choice B. And then again, this is absolute uncertainty. So we got delta V over V is going to be n times delta A over A. And volume is S cubed. So let's get our volume first. It's going to be 8.0 centimeters cubed. So we've got delta V over 8 equals 3 times 0.2 over 2. 0.2 2.0, just kind of keep this here. So I'm going to have delta V equals 0.30 times, and you know what, I'm going to make this 8.0 times 8.0, and this is going to give me 2.4 centimeters cubed, and this is a plus or minus, so that's how I'm getting choice D. All right, let's just make sure we got everything covered here. All right, that's an acceleration problem. Block acceleration problem, collision, stuff we don't know. So these are all the measurement and uncertainty problems that we need to cover on this exam, on this practice exam. This is the video. I'm going to put it in a haiku, but I'm also going to, in the study guide, you'll have direct links to specific parts of this video all for individual problems.